Hello everyone, in this video I explain solving inequalities. Let us start. First of all, we need to know the difference between inequality and equation. X plus 3 equals 5. This is called an equation. It has particular value for x. So this expression is true only when x equals 2. Because when we move 3 to the other side, x equals 5 minus 3, x equals 2. So the solution is one value or more. But just in this linear equation, it has one solution, x equals 2. What about this? X plus 3 greater than 5. This is called inequality. So the inequality contains any symbol like this, less than, greater than, less than or equal, greater than or equal. How to solve this inequality? Approximately it is the same like the equation. So we move 3 to the other side, we change it this side. So we write here x greater than 5 minus 3, x greater than 2. It means all the numbers which are greater than 2. So this is a solution. We represent the solution on number line. This is the number line. Only we draw open circle around the 2 because it is not equal, and then greater than we go to the right. So all the numbers greater than 2, so this is the solution. What is the difference between equation and inequality? Just when we multiply or divide by negative number, we have to flip the inequality. For example, if this negative x plus 3 greater than 5. How to solve this inequality? We move 3 to the other side. So negative x greater than 5 minus 3, negative x greater than 2. Now we need to get x, so we divide by negative 1. When you divide or multiply by negative 1. When you divide by negative 1 or multiply, take care, we have to change the direction of inequality. So it becomes less than. So you write here x less than, okay, 2 divided by negative 1, it's negative 2. So all the numbers that are less than negative 2, less than to the left. So all the numbers that are less than negative 2. Only this is the difference between equation and inequality. Let us we take example. In this example, it said find the set of values of x for which 12 minus 3x less than or equals to 27. We solve this. So the solution 12 minus 3x less than or equal to 27. How to solve this? We move 12 to the other side. It becomes negative. So negative 3x less than or equal to 27 minus 12. Negative 3x less than or equal to 27 minus 12. It becomes 50. 2 from 7 equal 5, 1 from 2 equals. Now what we do, we divide by negative. Take care, when we divide by negative 3, we change the direction of inequality. So it becomes greater than or equal. So x greater than 15 divided by negative 3, it's negative 5. We represent the solution on number line. Here we have equal, so it is closed circle. We close circle around negative 5, so because negative 5 with us, and then greater than, we go to the right. So this is the solution of the inequality. All the numbers greater than negative 5. Let us we take another example. In this example, find the set of values of x for which 4x plus 7 greater than or equal 3 and 17 less than 11 plus 2x. To solve these two inequalities, we divide this, and it means intersection. And it means the intersection of the two sets. So we divide the plane into two parts. 4x plus 7 greater than or equal 3. The other side, 17 less than 11 plus 12. We solve each one separately. The first one, we move 7 to the other side. So 4x greater than 3 minus 7. So 4x greater than 3 minus 7, negative 4. We divide by 4, it's a positive number, so we don't change the direction of inequality. Divide by 4, divide by 4. So x greater than or equal to -1. We represent the solution of this inequality on number line. Around -1, it's a closed circle around -1. It's greater than, so we move to the right. So this is the solution of the first inequality. For the second inequality, we solve it. We move 11 to the left. So 17 minus 11 less than 2x. 1 from 7 equals 6, so it is 6, 2x. How to solve this? We divide by 2. Also, we don't change the direction because it's a positive number. Divide by 2, 6 divided by 2 equal 3. How to read the inequality? We read the inequality from the variable. It is the same, we say 3 less than x, it is the same as x greater than 3, but it's better to read the inequality from the variable. So this x greater than 3, we represent the solution on number line. X greater than 3, so 3 it is not included, so we open circle around the 3. Greater than, so it is also to the right. So this is the solution. What about the two inequalities? We draw two number lines down each other. So this one is the first number line, and this is the second number line. We represent the two inequalities in order. -1 comes before 3. So we represent for the first one -1. So it is -1 here. It's closed, and then we go in this direction. So this is the solution of the first inequality. The second inequality, 3. 3 comes after -1. It's open. So this is 3. And then also we go to the right. Now the solution of the two inequalities is the intersection. What is the intersection? The common elements. Look, all of these are common elements. So the solution, all the numbers greater than 3. 3 is not included because 3 is not with us for the second inequality. So what is the solution of the two inequalities? X greater than 3. So this is the solution. Let us take another example. In this example, find the set of values of x for which x squared minus 4x minus 5 greater than 0. This is quadratic inequality. We know that before in the quadratic function, when the coefficient of x squared is positive, it will be open upward. We have, of course, 3 cases. If we have 2 roots, or 1 root, or no real roots. If we have, for example, 2 roots, so this is x-axis. So part of the curve up to x-axis, positive, part of the curve down to x-axis, negative. So in this part, it's positive. Y is positive, so the inequality is positive. Down, it's negative. If we have one solution, all of them is positive except at one root. How to solve this? This is graphically. We solve it algebraically. And then we check at the end graphically. So how to solve this? We say let x squared minus 4x minus 5 equals 0. Factorize to solve it. So it's x minus 5, x plus 1 equals 0. So x equals 5 or x equals -1. That are the two roots. We draw the number line and represent the two numbers in order. -1 comes first and then 5. Now we check the sign of the inequality. This is the inequality, it is a given. So we check the sign of x squared minus 4x minus 5. We check the sign of this one. We choose numbers. For example, we choose number between -1 and 5. The best number is 0. So when you replace x by 0 in this one, 0 minus 5, it will be negative. So between -1 and 5, the inequality is negative. The function, the quadratic function, it will be open upward or open downward. So if the middle term is negative, the other two terms are positive. If the middle term is positive, the other two terms is negative. So this part is positive, and this part is positive. You can check by choosing number. For example, you can choose number greater than 5, like 6, and choose number less than -1, for example, -2, and substitute to check the sign. Now this is the answer. What do we need? Greater than 0. It means positive. So when the inequality is positive, when x less than -1 or x greater than 5. So the solution of our inequality is x less than -1, this is a positive, or not and, or x greater than 5. If we represent this one graphically, so it comes like this. This is -1 and this is 5. And this part here up to x-axis, it's positive. So our solution in this one, less than -1 or greater than 5. Let us take another example. This example contains a quadratic inequality and the linear inequality. Find the set of values of x for which 12 plus 4x greater than or equal x squared and 5x minus 3 greater than 2. We start the solution. We divide the plane into 2 halves. We solve the first inequality, greater than or equals x squared. Let it's 0 inequality, so we move x squared inside. Then it becomes, we rearrange it also, it's negative x squared plus 4x plus 12 greater than or equal 0. Now we need to solve this inequality. To solve this inequality, we say let negative x squared plus 4x plus 12 be equal to 0, multiplied by -1, x squared minus 4x minus 12 equals 0, factorize 12, the two numbers, product 12 and difference 4, so it is 2 times 6. So x minus 6, x plus 2 equal to 0. X equals 6 or x equals -2. Draw the number line and represent the two numbers in order. -2 comes first and then positive 6. We check. We need to, what we need? We need to solve this inequality. It's okay? This one. So we choose a number between -2 and 6 to check the sign of this. The best one is 0. When you replace x by 0, it becomes a positive 12. So in between -2 and 6, it will be positive. Outside, it will be negative. Or you can choose a number less than -2, for example, -3, and more than 6, for example, 7, and do substitution. We need to solve this when that inequality is positive, when x in between. So the solution of this inequality, is x greater than, we have equal here. So we take the number -2 and all 6, because we have greater than or equals. So it's greater than or equals -2 and smaller than or equals 6. By drawing the number line, we represent that solution. So -2 is closed and positive 6 is closed and all the numbers between. So this is the solution of the first inequality. Now we solve the second inequality. In the second, it's linear, so we move 3 to the other side. 5x minus 3 greater than 2, move -3. So 5x greater than 2 plus 3, 5x greater than 5, divided by 5 both sides. So x greater than 1, 5 divided by 5, 1. We represent the solution on number line. So this is the number line, greater than 1. So 1 is not included. So open at 1 and take all the numbers to the right, greater than. So this is the solution of the second inequality. We need to solve both of them, and now what we do, we draw two number lines down each other. So we draw two number lines down each other. This is the first one, and this is the second one. The solution of the first is from -2 to 6. So this is -2, it's closed, up to positive 6, also it's closed. So this is the solution of the first inequality. The second inequality, 1. 1 in between -2 and 6. So this here, it's 1. 1 is open. And then we take all the numbers right to 1. Now we need the common numbers. the intersection between, because and means intersection, and means the intersection. So the intersection of the two intervals is that all the numbers after 1. 1 is not included, but 6 is included, because 6 is closed, but 1 is open. So the solution of the two inequalities is x greater than 1 and less than or equal 6. So this is the solution of the two inequalities. Let us we take another example. Let us we see this example. The equation x squared plus kx plus 8 equals k has no real solutions for x. First part of the question, show that k satisfies k squared plus 4k minus 32 less than 0. Hence, find the set of possible values of k. We start the solution to solve this equation. So first we move k inside. So it's x squared plus kx plus 8 minus k equals 0. We find a, b, and c, the coefficients of x squared. So a, the coefficient of x squared is 1, b, coefficient of x is k, and c, the constant, it's 8 minus k. To decide this one, he said has no real solution. It means the discriminant is negative. So the discriminant, because he said has no real solution, has no real solution if the discriminant b squared minus 4ac less than 0. Now we do substitution. b equals k, so k squared minus 4a is 1 and c is 8 minus k. This must be less than 0. We expand, so k squared minus 4 times 8 minus 32 minus times minus positive 4 times k, it's 4k. This one is less than 0. Rearrange this inequality, so k squared plus 4k minus 32 less than 0. This is the first part, part A. Show that k satisfies. So it is the same. Now we need to solve this inequality. This is the second part of the question. So we need to solve this k squared plus 4k minus 32 less than 0. How to solve this inequality? Let k squared plus 4k minus 32 equals 0. We factorize this. 32, two number product 32. Okay, it's 4 times 8. So k plus 8, k minus 4 equals 0. Two numbers, 4 times 8, 32. The difference is 4 and the product 32. So k equals negative 8 or k equals 4. We draw the number line, represent the two numbers in order. So negative 8 comes first and then 4. We need to check the sign of this inequality. So we choose a number between negative 8 and 4. The best number between negative and positive is 0. When you replace x by 0, it will be negative 32. So it's negative. Outside, of course, is positive, or you can choose a number less than negative 8, for example, negative 9. If you replace k by negative 9, you will get positive. More than 4, if you choose 5, it will be also positive. What do we need? Less than 0. Less than 0, it means negative. So what is the solution of this? It is in between. So the values of k satisfies this. So k greater than negative 8 and less than 4. Hence, find the set of values of possible. This is the set of possible values of k. I hope you understand this topic. Thank you.